Hello, if you are new to FEDn or have heard about FEDn but never get the chance to get started with your first example, this video is for you. Today I will cover three main things. First, I will introduce you to the different sections on our web pages where you can find more information about FEDn. Second, a step-by-step procedure to start your first example project all the way from nothing to running multiple clients. And the third is the terminologies that we use within FEDn framework when it comes to the execution environment. And in this video, I don't expect anything that is related to FEDn framework itself, but I expect that you have a basic understanding with federated machine learning. So with that, without wasting any time, let's get started with the very first thing that you need to do is to come to the Scale Out Systems webpage. On the first page, you can find quite a lot of information related to use cases, different applications that we are working on. And together with that, one thing that is important is that you will find the link to our workshops. Every month, we organize a free online workshop where the idea is that we discuss federated machine learning, basic concepts, all the way to a hands-on session where the idea is that all participants connect their machines and we jointly train a model. So if you are interested in that, sign up for the next workshop and join the session. Okay, coming back to the quick start guide, all the way up on this page, the very first page of Scale Out Studio, you can find a link called Framework. Click on the Framework link and here you can again find information specific to the framework. If you go all the way down, you can see that there are three guides available. The very first will take you towards the quick start. So let's click on this one. On this page, you can find on the left side all the documents available related to FEDn framework. It contains all the way to the very basic ones to the advanced ones related to aggregators, all these things. And on the page, what you will see is that all the steps that are required to start with your first project. The very first thing that you need to do is to create your account on the FEDn Studio. FEDn Studio is a public SaaS that Scale Out provides for everyone, and here the idea is that if you have an academic R&D kind of project that you want to get started with, you can create your account for free and you will get access to one project. So let's get started, and for that you need to click on this link. It will take you to the sign up page. You need to fill this form, and based on the information provided in this form, you will receive an email with a link. When you click on the link, your account will get activated, and after that you can log into the studio. So for that, what you need to do is to write fedn.scaleoutsystems.com. You will end up on a first login page, enter your username, password, and this is the first page that you will receive after that. So right now I'm logged in as Salman, and there is nothing much available right now because it's a new user that I have created. And on this on the top right corner, you can see that there is a project, there is a button called New Project. So whenever it comes to the federated machine learning frameworks, often there is quite a lot of initial complexity related to starting up services and connecting them together. At Scale Out, we have tried our best to provide as simple as possible kind of mechanism that can help you to get started. So for your first project, I need to write the name of the project, my first project. I can write this, and I need to press the create button. It will take a couple of seconds and then the project will be up and running. So the whole platform is based on Kubernetes. On the back end, how things works is that it basically initiates different pods, and that's how the system gets started. So now you can see that my services, the core services on the server side that help me in terms of aggregation, connecting different clients, all the necessary requirements, they are up and running. You don't have to do anything related to that. You just need to write the project name and everything will be available. So now we have completed one step that is related to how to initialize your first project. Here you can see that there are more tabs available. I will go into that in the later half of the video, but that's the first step, very easy to get started. Okay, before we start with the next step of connecting our clients to the FEDn Studio, I thought that it will be better if I can explain the terms that we often use when it comes to the FEDn framework. So the very first term is compute package. What is compute package? Compute package is a bundle that contains all the necessary scripts that are required to run the training process. So a compute package first contains a data loader that defines like how to load the data, training process, set of functions or one function that defines how the training will run, and validation if you want to run that on the client side. So it is basically a package that defines all the details that are required to run the training process on the client side. How it gets executed is basically, as a project owner, I need to upload the compute package in my project, and when I connect my clients to my project, the very first thing that happens is that the compute package get downloaded on the client side, and then it starts the execution process when there is a signal from the server side that okay, now it's time to start the training. That's the default way of using the compute package. However, if one side don't want to use an external compute package, they can write their own compute package and connect the client to the server side. So that's basically how we define compute package. The second is seed model. It is basically the randomly initialized weights on the model. Again, it has to be uploaded on the server side and it get downloaded on each client side. That basically starts the training process on each client side. Then when it comes to the connection from the client side to the server side, is that happens basically based on a client config file. When you create a project, there is a possibility that for each client you can download a client config file. Based on that client config file, a client get access to the project. So that's how things work. Now what we will do is that we will actually create a compute package, we will prepare a seed model, and we use the client config file to connect everything together. So now we have completed the first step. The next step is to connect the client. For that, the very first thing that we need to do is on our local machine, we need to install FEDn library. For that, you can use the pip install FEDn simple command, or you can use the source. And for that, what you need to do is to download or clone the repository, go into the directory and run the pip install command. So I will use the command pip install and install FEDn library on my machine. For that, here is the machine that I'm using. It's a Linux machine, but you can use any machine, any operating system like or Windows, Linux, or Mac. Okay, so if I now say FEDn, it's not available, but if I write this command, it will start installing a couple of packages and make the FEDn system available. So now if I say FEDn, I can see, yeah, now FEDn is installed with different options. If I say minus version, so that's the version available on my machine. Let's go back and see what's the next step. The very next step that we would like to achieve here is to create the compute package. But this compute package need to be according to some example or use case. The example that we will use today in this session is the MNS PyTorch example. I can show you the open source area where we have provided couple of interesting examples. You can pick any one of them, but in this video I will use the MNS PyTorch. So if you go to the git scaleoutsystems.com, you will end up on our organization page, and here you can see we have FEDn, the first link available. So if you click on the FEDn, you will see that this is basically where we provided all the examples and the whole package available here. So if you click on the examples, so these are the examples available. These are different examples based on like different kind of use cases, and the one today that we will use is MNS PyTorch. We have Keras model, we have Hugging Face example. Depending on your choice of example, you can pick any one of them and get started. So for that, the very first thing that we need to do is to download the example folder and make it available on our local machine so we can prepare the compute package. I have already done that. So here, if I say ls, you can see that the FEDn folder is available. And if you want to do that, you just need to go to the quick start guide and just simply clone the repo. Once you clone the repo, you have this folder available, FEDn. And if I go inside the FEDn directory, you can see all the files and directory. I need to go to examples, and here you can see all the examples that I showed you on the GitHub page. So as I said, that today we will use this Venice PyTorch, and this folder contains all the information related to this example. So the next step, as I said, that is to prepare the compute package, and compute package is basically what files are available in the client folder, because that is what gonna run on the client side. So if I go inside the client folder, you can see what we have here is all the files that actually defines the training process, validation process, how the model will look like, and all the other information that you would like to have, or what project owner would like to run on the client side in terms of completing the training successfully. And also here you can define how the data you want to load the data. If you want to have another step after loading the data to just check that the data is correct or not, you can have other options as well. So this is basically the folder that actually contains everything. What we will do is that we will create a bundle based on this folder. So we need to go one step back. So right now I am in this directory, FEDn example Venice PyTorch, and the example or the command that I need to run to make the compute package available is available on this quick start guide. So this is basically the command that I need to run on the machine. So copy, and let's go back, run the command. So the command said FEDn create a package based on the path of folder name client, and the client folder is available in the same directory, right? So when I run that, it will just create a bundle file called package.tgz. So here you can see now I have a new file called package.tgz. Okay, the next thing is create a seed model. For that, again, I need to use the same example folder to set up everything and generate the first model that we call the seed model. For that, very simple, just simply run this command, and it will take a couple of minutes depending on the kind of computer that you have, internet connection, because it needs to install some packages, and then the seed model will be ready. So if I paste it here, again, this command is very simple, FEDn run build, because this time we don't only need to package everything, we need to run a couple of scripts, make the model available, and prepare the seed model. So when I run this command, you will see it will start installing a couple of scripts that basically provide the whole environment and then prepare the seed model. It will take up. Now the process of creating the seed model has been completed. The steps that we have covered so far, if I start from the beginning, we have created a project, we have installed the FEDn client libraries, and together with that we have prepared our compute package and seed model. So that's the last command that I run on my client side, and here you can see that if I say ls-l, you can see that now I have two new files, package and seed. The next step is to make these files, package and seed, available to the server side. So let's go back to the FEDn Studio. Here we have our project. I need to go inside the project, and that's the area where I need to upload my compute package and seed model. For that, you need to enter in this session area and create a new session. The new session will require you, first of all, to upload a compute package and seed model, because session is another term that we use in FEDn, that is basically the collection of different rounds. So whenever you want to start any training process, you need to make it sure that you have a compute package and associated seed model available. So first what we will do is that we will just write my first package, and I will take it from the I have already downloaded the compute package, and this here compute package, it's available here, and I can upload the compute package. And now I need to upload this seed model. For that I need to pick the model file that I have prepared. I upload that seed model as well, and now both compute package and seed models are available on the server side. The next step is to go and connect the clients with the studio. But for that, as I said, that I need to prepare, or I need to make a client config file available. For that, you need to click on this client section. Here you can see currently there is no client available in this project. Using this button, connect client, I can create a client config file that allows a new client to connect to the system. And for that, here you can see that this step we have already completed. We have installed the FEDn libraries. The next step is to download the file. So if I click on this one, you can see that I can download a new client config file. I have already opened one. So let me copy paste the contents. So if now I say, let's clear the screen, and again, once again, I can show you I'm in this example manage PyTorch directory, and here I would like to create a new client.yaml file, and these are the contents that I have downloaded from the server side for my machine. And this, based on this client file, the client will connect to the server side. So now if I say ls-l, you can see that I have 3 new contents in this folder. First, I have created the compute package, I have created the seed model, I upload both of them to the server, and then I have this client.yaml file, and this is the file that allows my client to connect securely to the server side. For that, what we need to do is to run the command FEDn run client, and this command is also available here if you go to the quick start guide. So these are basically, this is the step where you can see that how to upload the model, compute package and seed model. We have done that. You can also do the step of uploading compute package and seed model via APIs. We are not going into that area in this video, but in the upcoming videos I will work more on the APIs kind of interfaces, and there I will explain more about APIs interface. Okay, so next the step is that just simply run this command and your local client will be started and connect to the system. So let's copy the command. Let's go here. So what this command said, FEDn start a client using the client.yaml file available in the same folder here, client.yaml, and with some flags, secure and SSL related ones. So once I will start this command, you will see that first the system try to identify if all the packages and the setup is available locally or not. If it is not available, then it will create a virtual environment and install all the necessary packages, libraries, and everything that is required to run your client successfully. This step will take a couple of minutes depending again on the size and the size of the model that you want to run, the packages you want to install, and also the amount of compute resources that you have. So I will get back once this is finished and we will see how it looks. Okay, now the client is active on my side. So here you can see the last message, client is active. And if you see the log messages, one important thing that you can realize is that how we have prepared this whole example is that since we are using an open source data set that's freely available, we don't want you to download the data set and then start the training process. The data loader that we have defined already have routines that actually downloads the data and make the data set available on your client side. So if you want to read more about that, you can see some messages in the log, in the logs that we have. Otherwise, you can also open the data.py file in the client directory and see how the data get available for the client. Okay, now on the command line side, I can see that my client is available. Let's go and see how it looks like on the server side. So let's go to the client section again, and here you can see one client name, client 467 is available and it's up and running. The status is green. So once the status is green, it means that the client is active. And let's see if I just close the client here, just by pressing this Control C, you can see I need to refresh the page. It will take a few seconds for the update. Yes, and now you can see that the client is not available anymore. But still the system keeps track of what previous clients have joined the project. So I just need to go back and start my client again. This time, since all the packages, everything is available, the startup of the client will be very fast. And soon, once the system set up everything correctly, the client is client get active again. So now we can again see that the client is active. Let's go here. Here we can see the client is active. So, but one thing that is also very important to understand that what it means when we start a client. So let's go back and see how things look like. So here I can just close the, I just terminate the client for a minute. And I can show you one more thing. If I say ls minus l in the same directory, you can see that there is a new directory that now we have in our example directory called package. So package is the directory that contains all the dependencies, everything that is required to run the client, right? So if you go inside the package directory, we can see that we have a client and the data folder is there, and the data folder there basically contains all the data set that will be used by the client to run the training process, right? Okay, so we will not go into these details. Furthermore, let's start our client again. Once it is up and running, then we can start our first training round based on one client. So now the client is active. Let's go to the session, and there is no session available at the moment. I can create a new session, and this time what I can see is that since I have already uploaded a compute package, it can show me that okay, this compute package is ready. If you want to change a compute package from one version to another version, you can add a new compute package. Same for the seed model. You can add multiple seed models, and in different sessions you can either use different compute package or seed models depending on the requirement. Okay, now let's go to the start session area. So that's my first session. So session ID 1, I would like to run 5 rounds, and as I said before, session is just a collection of different rounds, and in federated machine learning, when it comes to the round, is basically how many times you want client to run the training process. And then round timeout is basically a threshold that we set on the server side, how long the server should wait the client to respond. And you can set other flags like you want clients to validate or not, or all these things. So now we have one client, everything is set up. Let's start the training process. So press the training round, it shows training has started. Let's go and see what is happening on our client side. You can see that training has started, the system is calculating loss, and all these things are happening. Let's go to the server side. What we can see on the server side is basically, if I can click on this session view area. You can see I have only one client available, and all the other details that are required to to report when it comes to the federated machine learning process, like for example test loss, more related to the model. Basically test loss, test accuracy, training loss, training accuracy, all these things are available. And if I go to the model section, I can see that 2 rounds has been completed, and in total we have started the 5 rounds, so there will be 3 more rounds, and in each round we are preparing one global model, and all these models are readily available through this platform. Together with that, if you click on the event section, you can see that the system also reports that what is happening on the client side, so that the model owner, or you can say the alliance admin or the project owner, get this understanding how the clients are working. So currently we have only one client. All these log messages are related to that single client. So overall, that's how it looks like when you have one single client connected to the system. So now all these 5 rounds has been completed. Here you can see the one plot related to training loss. If I click here, test accuracy, you can see that's how the accuracy, how we get the accuracy based on different rounds. So that's how everything looks like. Let's connect one more client and try to understand whether every time we connect a new client, it also takes the same amount of time, or there are more options that one can play with on the client side. Okay, so far we have achieved 5 rounds based on one client connected to the system. Now what we would like to do is to connect one more client. For that, again, the process is very simple. We just need to run this command. But as I said that the client connection is based on the client config file, we need to download a new config file, and using that config file, I can connect another client. So let's go back to the studio. In the client section, again, right now there is only one client connected to the system. I need to again click on the client connect and download a new file. I have already done that on my side. So let's go to the command line and see how it looks like. Here I'm running one client. In this tab, I'm in the same folder, examples MNS PyTorch, and here I would like to create my second client, client1.yaml. If I just copy paste the new client config, and here the client ID is 869, right? So now let's save the file, and you can see how the directory structure look like. Now I have 2 client config files. What I need to do is to run the same command again, this one. So now I'm again would like to start my new client with the configuration file, but this time I don't want to use this configuration file. I would like to use the new configuration file for me. And one more thing that is important here is that as long as the compute package is in the same directory, what will happen is that the system will not create a new complete package. It will just use the configuration file to connect to the system and use the same package to start the client, the second client. Now once I will start this, I will run this command, what will happen is that I will have 2 clients using the same dependency package. But if you change the directory, then system will again install a new the package folder. Or if you specify based on the flags, you specify the new place where you want to have the package directory, then that there will be a new folder created. So let's start a second client. It will take quite less amount of time and get started very quickly, because all the packages, everything is already available in the folder. So now you can see my second client is up. I can go to the system and see, yeah, the second client is up, and it's much faster than the first one, because for the first we need to prepare the whole package. So far so good. Let's go and start the second session. Again, compute package, I'm using the one that I prepared before, and the seed model is there as well. Session 2, 5 rounds, same round timeout, same settings. Start with the session, and if I click here, you can see that right now there is no option available, no information available related to the preparation of the model or how the client respond towards the system. But now you can see that we have two clients, both responded to the server, and they have completed one round. In this session, the first round is round number 6 because 5 rounds were completed in the last session. So that's how things work. So that's what I would like to cover in this video, based on like starting from having not even an account on the studio to all the way starting your first project running different rounds. So in the next videos, I would like to highlight more about like how you can customize different compute packages and also how different data loaders can be used. So thank you very much for listening.